I'd like you to start by doing this warm-up on your own piece of paper. When you are done and you're ready for the answers, press play. As you can see, the first angle is a right angle that's exactly 90 degrees. The second angle is acute. An acute angle is between 0 and 90 degrees. And the third angle is obtuse. It's greater than 90, but it's less than 180. In number 4, it tells us the perimeter is 47, and we want to find x and the lengths of the three sides. So in order to find x, I add up my sides, 2x plus 6, x plus 3, and 3x plus 8. I set it equal to 47, and then I solve for x. I get x equals 5, and then I plug x into each of the side lengths, and I find that my side lengths are 8, 16, and 23. Press pause if you need to go back and check your work. If not, keep watching. Today we're going to talk about classifying triangles. We will be taking notes on a guided notes sheet. The first thing we need to talk about is what a triangle is. A triangle is a polygon with three sides. There are different parts of a triangle. The parts of the triangle are the segments that make up the sides. The sides of the triangle in this triangle are segment AB, segment BC, and segment AC. Notice I've written a bar over the top of each one. That's the name of the segment. The vertices of the triangle are points A, B, and C. We can classify a triangle in two ways. We can classify it by its angle measures, and we can classify it by its side lengths. As you can see, we have acute triangles. These are the ways I can classify a triangle by angles. The first is an acute triangle. It has all three angles acute. The second is equiangular. All three angles in the triangle are congruent. I have a right triangle where I have one right angle in my triangle, and I have an obtuse triangle where one angle is obtuse. Now, down at the bottom of your paper, the screen, we have a triangle over here, and we'd like to classify each triangle listed. Triangle BDC is here, BDC. And you can see I drew it separately because it was kind of small and I wanted to be able to write in it real well. So it's hard to tell, but this 100 degrees is angle B. And then I was able to find this angle over here, D, by knowing that the angles in my triangle sum to 180. So I know 100 plus 110 is 110. 180 minus that is 70. Now, in looking at this triangle, I can see it has one obtuse angle, and therefore it is an obtuse triangle. I could have answered that without even knowing this was 70 degrees, but I still wanted to show you that. Now, the next triangle I have to classify is triangle ABD, and you can notice that I wrote my triangle over here on the right-hand side because it just was too small to write in. I see this angle over here is 20 degrees. Angle A is labeled 80 degrees. And I know this angle B has to be 80 degrees because these two angles right here and here make up a linear pair. If angle B here is 100 degrees, that must mean the angle B on the other side is 80 degrees. So as I look at this triangle, I can see that it is acute. I want you to give this one a try. Classify the triangle by its angle measures. When you're ready to see the answer, press play. So you can see my first triangle, FHG, is right here. That's equiangular. I found that the top angle here was 60 by taking 180 and subtracting 60 and then subtracting 60 again. So that's equiangular. EHF is over here. And I found that this was a 120 degree angle by subtracting 30 and 30 again from 180, so that's 120, and that's obtuse. The last triangle is EHG. EHG. This angle up here is a right angle, therefore my triangle is a right triangle. And in case you haven't noticed by this point, we name our triangles by their vertices. Let me go back here. So we name triangles by vertices. Make this smaller. So you can see we put a triangle in front, a triangle symbol in front to indicate that it's a triangle, and we name it by the vertices. We can also classify our triangles by side lengths. And you can see in our first triangle, it's an equilateral triangle where all three sides are congruent. In an isosceles triangle, I have at least two sides congruent, and that is very important, at least two. So an equilateral triangle is also isosceles. Equilateral is a more exact term for it, but it's also isosceles because it has at least two congruent sides. A scalene triangle has no congruent sides. So down below you can see that I've classified my triangles. I have triangle EHF. Here it is, EHF. Do you see how this segment here is marked as congruent to this segment there? That means it's isosceles. While segment EHG, I have one side that's 12, I have another that's 11, and I have another side that's 14. Therefore, it's scalene. I want you to press pause on your video and classify these triangles by their angles and also by their sides. And when you're ready to see the answers, press play again. Okay, my first triangle, MNQ, is acute and it's equilateral. Now, one thing I haven't told you at this point is that the angles in an equilateral triangle are all 60 degrees. Every single one of them is 60 degrees. So while it's acute, a more exact term for it would be equiangular. Okay, so all equilateral triangles are equiangular, and vice versa. So make sure you write that down in your notes as well. Triangle NQP is over here. NQP is obtuse. It has that 120 degree angle, and it's also scalene because all the sides have different lengths. MNP is over here. It's the outside triangle. It's acute. Each of the angles is less than 90 degrees. This angle is 40. This top angle over here would be 80, and angle M is 60. So it's acute, and it's also scalene because all the side lengths are different. Notice that this is an isosceles triangle. I want you to set up an equation and solve for x. Press pause on your video, and when you're ready to see the answer, press play again. So what I did was I set 3x plus 2 equal to 4x minus 7. 3x plus 2 equal to 4x plus 7. I solved for x by subtracting 2 from both sides and subtracting 4x from both sides and then dividing by -1. And then I found x must be equal to 9. To find the side lengths, I substituted back into each of the expressions. I wrote plus 7, it should have been minus 7. Excuse me, let's see here. I knew something was wrong. Get my eraser. This should have been a minus. So I would have subtracted 2 from both sides, and that would have given me negative 9 on the right-hand side. And I subtracted 4x from both sides, and that would have given me negative x. Divide both sides by negative 1. X is equal to 9. And then you go back and you plug in. Okay, I want you to try this. Press pause on your video and press play when you're ready to see the answer. Okay, the first thing I did was I set 4x minus 10.7 equal to 2x plus 6.3, and I solved for x. You can see that x is 8.5, and then I plugged into each of these. So I found 2 of my sides are 23.3, and the other one is 44.5. I have put some flashcards out on Schoology for you to review. Make sure you review that tonight as part of your assignment, and also do the assignment that's posted online. Have a great day.